Hello and welcome to Metro Home Theater Tech Tips. I'm Brent McCall.
I'm Adam Rogers.
And today we got lots to go over with EDID, Captain, my EDID.
Yes. So, yeah, lots to go over today because there is a lot involved with EDID.
And by the way, this is part one.
This is it. Yep, there we go.
Just in case you guys are wondering, we are washing our hands, keeping our distance, and under normal circumstances,
wearing our masks.
So,
yeah, so anyway, so with our, when it comes to EDID, there's a lot involved with it. So today we're going to be talking about what is actually included in the EDID channel, and the other types of information that's passed down, the information that's talked back and forth on the EDID channel, and just how important it really is. So we'll be getting into details about that today. We're going to be talking just real quick about some calls that we had.
Oh, it's a good one this morning.
A really good one this morning.
It was quite enlightening.
Yeah, so stick around to the end. We're actually going to be talking about that later on.
But before we get there,
yep.
What is today's sponsor?
Today is sponsored by the letter J.
And why is it sponsored by J?
Because it's sponsored by the HDM JR3. J for the Junior 3. And
what does the Junior Junior 3 do for us?
It does a lot. So primarily the Junior 3 is an EDID capacitance stripping device.
A repair tool, an accelerator.
A repair tool, an accelerator. So if you want to talk more about that, because you know a lot more about it, because you were part of the development on this.
Now, the Junior 3, which is a new form factor, which is really nice, is the culmination of many things we have been learning over the past 12 years, starting with our original HDM DAD, which is this big black box right here. So as you can see, we have gotten a lot smaller and a lot more convenient through the years. What it does for you, and we will get much more in depth in this in today's video, is it strips capacitive loading off the data bus. Basically, capacitive loading puts a chokehold on the information traveling between the source and the display. It's all about time. And if the data is not communicated in a timely manner, the system collapses. So we will get very in-depth in that today and discuss why and when to use the JR3 and the AIO2.
Yeah. So, as always, everybody, thank you for checking in with us today. If you have questions while we're going through today's episode, leave them down in the chat. If you're checking on this video after the fact and you're watching it afterwards, leave your comments and questions in the comment section below. We do check on those daily. In fact, we had a really great response to last week's episode, which I do want to talk about when we get into our tech support. We did, but in a good way, and I want to talk about that when we get to that. But as always, leave those comments and questions, any ideas that you may have, even if it has nothing to do with what we're talking about today. We would love to talk about tech and different things that you're running into. As always, a subscribe is really helpful to us and lets us know that we're doing things right. A like and a share, comments, all that kind of good stuff. Also,
get us to 1,000.
Yeah, get us to 1,000. Actually, we're at 926 as of this morning, so we're getting closer there. So we made it over the 925, which is great. Thank you so very much to everybody who subscribed. Share it out to anybody who you think this is some good information for, and we'll talk some more about that as we get to it.
And one more thing before those of you who have not seen the Facebook post, Adam just posted up a video on the AIO2.
Yes.
Interfacing with the Control 4 system and how to properly program it into the Control 4, and it is a phenomenal video.
Yep.
It is very much worth your time to watch, and Adam did a great job on it.
Well, thank you very much. I appreciate that.
I don't give out
I was going to say, it's not very
often
I get a compliment from you anyways. No. So, yes, again, as always, everybody, thank you for checking in. Leave your comments and questions below, and we'll get to them as we get there. So, Brent, where'd the Junior go? What'd you do with it?
I put it right there.
You put it right there? Okay.
By the dad.
By the dad. There you go. Okay, so, now, actually, that's the second generation. That was the one before the newest one.
On top of the dad.
Which is the Junior 3. So, when we are talking about EDID, now last week, let's just do a quick recap. Last week we talked about the 5-volt power coming from the source device. We talked about the hot plug return and how...
We talked about voltage and we talked about current.
Right. So in that discussion we talked about how the 5-volt power is the knock-knock. The hot plug return is someone inside saying, who is it? Now we're at the point where they're discussing, they've opened up the door and they're discussing who they are, what they are, what they're there for.
My analogy actually is closer to a sales process.
Okay.
So someone walks in your door.
Yep.
You hear the doorbell go ding, ding, ding. You have a customer. That's the 5-volt.
Right.
Hello, hey, welcome to my store. That's the hot plug.
Right.
Now the real sales process starts. And this is the exact same thing that happens in HDMI.
Yep.
So a lot of things have to be discussed. And it's all, what can the source give and what can the display understand? So it's a lot of questions like, who are you? What are you? What's your firmware? When were you built? Who made you? What feature sets do you have? What resolution do you want? What bit rate? What color depth? Do you want HDR? If so, what kind? Do you want audio? There are many lines of code that have to be discussed within the EDID before the picture and the sound ever actually start.
Right.
And that's, honestly, that's the delivery of the sale.
Yeah.
So until you get the sales process and the sales close,
Yep.
which is HDCP,
Yep.
you know, cash, check, charge, or
Yep.
firstborn,
All that good security.
until all that happens, you get no audio or video. So we're going to discuss the basics of EDID right now. And on that note, would you give me an overhead
sure
and
will.
a black marker?
Yep, you can go for the black marker there. Now, if anyone's keeping up with us about this, we've talked about the different channels. Now, the EDID channel, that's actually the physical line that we work with. Brent's going to show something different here. However, if you're keeping up with us...
I'm not talking the physical cables.
Correct. You're talking the design.
I'm talking what it is.
Yeah. So if you're keeping up, pin number 14, 15, and... let me see. Nope, I missed it. I'm sorry.
Was
Pin number
18,
15.
19.
Nope, it's 15 and 16.
Oh, that's what I'm thinking, 5 volt.
Right. 15 and 16 are the EDID channels. You get positive and negative for those. It's actually a form of serial communication, if I understand correctly.
Yes, it is. And basically, it's RS-232.
Yeah.
This is not modern technology. This is old school communications.
Right. Now, it's actually using pin number 17 as its ground. So you have positive and negative for 15 and 16, and pin number 17 for its ground. So, Brent, what are you drawing?
I am drawing basically what a waveform looks like and how it operates. Now, interestingly, and we've all seen post online that digital's digital, it either works or it doesn't work. Yeah.
That's funny.
Now, here's the thing about digital. Digital is still an analog waveform, it's just red at the top and the bottom. So how is it and where is it red? Well, here's where it gets intriguing. The EDID or I2C standard at this point is about 35 years old. It was developed by Philips, way back a long time ago as an intercommunication for plug and play within computers. It had nothing to do with HDMI. Now, when Philips set the standard, it was assumed you're going to go 3, maybe 6 feet between a PC or a computer and a display. It was never meant really to do the distance we're trying to do. However, there are certain things that do translate well to HDMI, and this is one of them. So this is, we're going to assume, is an HDMI waveform graph. Now, what the waveform looks like, in theory, should be this. Now, this is a rise to 5 volts flat, because we're showing that a consistent voltage here, and then a drop to 0 volts is what people assume EDID is. It isn't. It's actually 4.7 on the high side, and the low side gets reasonably ambiguous.
That's a big word, Brent.
Yes, and I actually like it because it's got 3 full syllables in it. Four.
Ambiguous. Ambiguous.
Now, here's the thing about this and why it causes problems. Kaleidoscape.
Oh, Kaleidoscape.
Kaleidoscape.
We love Kaleidoscape.
It's a phenomenal product,
It really
and they've
is.
done nothing wrong.
Yeah, no, they really haven't. And in fact, they followed
the rules
very closely to the rules.
They just did better than the rules. Here's the thing.
They're that one kid in the class who was like the perfect, student.
Yeah, the one everybody wants to beat.
Yeah, pretty much. Yeah. But hey, it's a really good kid in that class doing everything they're supposed to do. It's just
so the way HDMI works is 4.7 is a mandated high. And if you hit 4.7 volts, you're considered a 1. We're going to call that a 1. That's a 1.
Is that a 1, Brent?
That's a 1.
Okay. There you go.
There you go. Now, what's a 0? Well, here's where it gets kind of iffy because Philips, in their infinite wisdom, said anything below 0.9 volts may be considered a 0. Not must be, but may be. Now, by saying may, they did not establish that 0.9 volts is the number. They just said anything beneath it. Kaleidoscape and a few other products require 0.6 volts. Now, everything in the waveform could be perfect. Everything. You got great rise time, and we'll get to rise time in a second. We got great, we got a good flow, everything's happy. But if you're running an AOC or an active cable, and that's where we first came across this problem, and most extenders,
Yep.
either coax, Cat5, or fiber, they're going to give you a 0.9 swing because that's the accepted answer.
Right.
The Kaleidoscape product does want to see 0.6 volts. And again, it's not that it's wrong, it's just different.
They're just sticklers. They just want to,
And
be
the
as red
chipset
as possible.
they developed, or the chipset they purchased for this, is a very good chipset and provides the best possible video, and they wanted to make sure the best possible communication. So they want to know that it's a low. But active cables, pretty much of any variety and extenders, don't give that low. So as we've discussed in the past, the AIO2, the JR3,
Yep.
the GA1, and the GA2 all adapt to that, actually taking it down to 0.4 volts. But that's not what we're here about today.
Right.
What we're about today is this. Now, this in theory, if you'll give me the overhead, is a perfect waveform. The drawback to a perfect waveform is you would have to have a black hole from here to here to have zero rise time.
Right.
And this is all about time. There's a clock here that's happening. So you actually wind up with something more like this. As long as we're like that, we're okay because there is a clock. There's a clock in all these groups, all the way down, that is looking for this. Is it high or is it low? It doesn't care what it is as long as it can read it as high or low. It's if for any reason the rise time slows down and is not high when that clock strikes, that's when you have a fail. And it's the same thing going the other way. If you have an exceptionally long drop, it's not going to be there and it's not going to be ready high or low when the clock ticks. Now remember I said this is an analog waveform. You've got a waveform. It has to get from here to here. It's not black hole. It doesn't just traverse through time instantly. It still has to get there. There's still electrical flow, and electrical flow takes time.
Now, this is actually something that all manufacturers of any type of electronic device have to deal with. This is something that your computer, the processor inside of your computer, has to deal with, because as much as we like to think that computers are ones and zeros and it's digital on or off, it is, but it's that threshold. It has to get there first in that amount of time. And that's really what's limiting everybody in those designs.
The thing to remember is this part is not digital, only this part is, where it's red.
Right.
So if for some reason...
Not read the collar, just read where you read it, where it's been read. Correct?
Or your shirt, yes.
Or my shirt, yes. Yeah.
So as far as the HDMI device is concerned, this doesn't exist.
Right.
Because it's not noticing the data at that point.
It doesn't care about that data because all it's looking for is the data to be here at this point at the high and down here at this point or at the low.
One or the other.
Yep.
This is what EDID is all about. Now, anybody that's done the old school dip switches understands the numbers 0, 1, 2, or 1, 2, 3, 4, or 1, 2, 4, 8, 16, 32, 64, is how data is added up. That's how you get your bits. And we'll cover that further down in the video portion of HDMI.
Yes. Yep.
The Team DS.
That should be episode 5 and 6 if I remember correctly. So.
Okay.
Yeah.
So the data is super critical. Now what causes the data to slow down is capacitive loading. Now capacitive loading simply is a chokehold on the data. And those of you remember, capacitance lags, inductance leads. What's a battery?
It's something that holds power.
And what's a capacitor?
Something that also holds power.
Exactly.
Yeah.
So when you get capacitive loading on a data bus, things slow down. Now, why do you get capacitive loading on a data bus? Now, we're looking at an HDMI cable that we have dissected, so this is not correct.
Yeah.
But you'll have a twist ratio on here. And that twist ratio is very critical to speed. And not just that twist ratio, but also the circuit board design in each of the devices, the quality of the soldering in the joints, the thermal properties of all of your devices.
Yep.
It's not typically a single thing that causes a failure. It's a cumulative failure. Now, the wonderful thing about EDID, it's not like video where you turn it on and you see sparkles and it's like, oh, I got a problem.
Yeah.
You may not know you have a problem for months.
Yeah.
It could be minutes, not often.
Yeah.
Unless it's really bad.
Yeah.
Weeks or months typically is it. So capacitance builds up over time. And when capacitance builds up,
you're looking for that. There you go.
The rise time starts to slow down. So instead of having that beautiful nice waveform. We wind up with a waveform that looks more like this. And when that happens, it's no longer in position when the clock strikes. And this is not instantly, this is over time.
Right.
This is being a minute late at every bus stop.
Yeah.
So that minute turns into 2 minutes, it turns into 3 minutes, turns into 4 minutes.
It just keeps getting pushed back and back and back and back.
Much like the mail under currently.
Well, not to get political, but yes.
So when it gets far enough out of whack, the system collapses and fails.
Right.
How do you fix it? Well, as the integrator, you go out there and you look and I don't know. You pull the cable out, you plug it back in, and by golly, it works.
Man, you're a hero.
I'm going home.
Yep. And then what? 2 weeks later, 3 months later, yep.
Same thing happens because the failure adds up. Now, how do you stop that from happening? Well, you don't allow the capacitive loading to build up.
Right.
And the simple answer to that is the HDM Junior 3 or the AIO2
right.
or the DAD or the GA1 or the
yep.
GA2, all the devices that we have, this strips capacitance loading off the data bus. It's an inexpensive tool that everybody should have. Now, what are the symptoms of capacitive loading on the data bus?
Well, I mean, you already kind of started talking about it right there, where you're saying that it's throwing the time off and then
yes.
adding, seconds after seconds or milliseconds or whatever it is.
What's the first symptom you typically see?
Do we lose? We lose something. We lose
audio.
Audio.
Audio is actually meant to fail first.
Okay.
Under the HDMI specification, audio has the tightest threshold for rise time.
Okay.
And it does that on purpose. The other ones are a little sloppier. Mm-hmm. They do that, again, on purpose. They want something to fail to let you know there's a problem. You have an idiot light on your dashboard.
Yep.
Now, it's not like the oil temperature gauge, the oil pressure gauge, or any of those that are very specific.
Nope, it's just saying
it's
something.
Just, something's wrong.
Something's not working right.
So audio will drop out typically first. The next thing that follow will be HDCP support, mode out of range, frequency out of range, right. black screen, or in really bizarre situations, you'll get weird color shifts or purple screens.
Yeah, that's where you get like the green kind of takes up
yep.
a part of the screen, or
because
purple kind of all over like that.
Because it's not making the proper connection to determine what it should be outputting.
Right.
And there's tremendous amount of options inside of every device.
Now, some of the other things that you could run into as well, and correct me if I'm wrong, but you could also see wrong resolutions showing up on the screen.
Absolutely.
You could see like a 480p image on a full HD source and display.
Or the whole picture shifted sideways or compressed.
Yep, just some weird, odd displays like that. So if you're seeing something like that, give us a call. As always, give us a call. 386-492-8584. That's the quickest way to get to me and our tech support team. Of course, you can call Brent at 866-839-9187, extension 2203.
And that follows me after work.
Yes. So
now, the way to find out if you have an EDID issue,
mm-hmm.
typically, honestly, unplug the cable, plug it back in.
Yeah.
If the problem resolves itself, at least initially,
right,
you are absolutely a candidate to put the Junior 3 in place.
Yep.
And fix your problem.
Yeah.
Now, other things to consider that also cause this. Thermal issues, environmental issues. Don't put the gear in a cabinet with solid doors.
Right.
Don't stack your DVR above your AVR.
Yeah.
Don't stack DVRs on top of each other. Don't put your cable box right on top of your AVR. If you have a media streamer,
yep.
leave room. If animals step to the far side and you look in our rack,
yep.
this is a working rack. We space our stuff out on purpose. We have to know that if there's a failure, mm-hmm. the failure is not because of something in the rack. Yep. The failure is because of something happening within the EDID or the HDMI chain.
Now, as always, this is our lab, and so this is our working environment. You can see it's kind of a mess right now. But like he's saying, we need to make sure that the equipment that we're using in our testing facility, in our lab here, is good working equipment. So if it heats up too much, I don't know if it's a bad device or if it's a bad cable. So
yes.
at that point, then we need to verify.
There are times we will induce failures.
Yes.
For testing products.
I think I have the cable. No, we were just doing a video about that in the other room. I have an HDMI cable that I purposefully damaged for that purpose.
To show the results.
Yep, exactly.
Now,
so
unfortunately, as we discussed last week, the failures of HDMI are,
yep.
regardless of the cause, the symptoms pretty much the same.
Yeah.
A black screen,
yep.
long time to sync, mode out of range, frequency out of range, HDCP not supported, or sparkles or weird color shifts.
Yeah.
And now we're back to the exact same thing we talked about last week, current.
So before you get into current, I got a question from a viewer. So Heather is asking, hi Heather, thanks for checking in with us. What baud rate is EDID?
If you'd asked me that 12 years ago,
I know, right? That's
if
a
you'd
good
asked me that
question.
12 years ago,
I'm gonna have to look that one up.
I honestly, I don't know.
You know, honestly, with
115 would be my guess.
115. Let's see, baud rate of HDMI.
HDMI
Let's find
EDID.
out.
I honestly don't know.
Actually, we'll go ahead and do EDID. So yeah, really great question because truthfully, you're correct. It's RS-232.
Yeah.
It's just serial data. So that's a really great question about that. Let's see if we can find it out.
Sorry.
Anyways, but yeah.
Yeah, there would have been a time, but it was long ago.
How about this? While I look it up, why don't you go ahead and jump into talking about the current? Yeah.
Okay. Now, current is very important for all of this. And as we mentioned last week, the display is responsible for providing current for the bus. Now, with EDID, you have to have at least 55 mils on the bus. Anytime you throw in active cables, AOCs, extenders, you have to make sure that you have, I highly recommend devices that have their own power, that they're not pulling off the bus. I do know, in fact, we saw them, there are some AOC cables that do not require power. A year and a half ago, I would have said, great, go with it. Now we're starting to see cost cutting on manufacturers from televisions that is causing issues. I'm going to recommend against it, or use current voltage supplementation. Now, while he's looking up that on EDID, are you find an answer yet?
I'm looking, not yet.
I don't know if you're going to find it instantly. It's like, that was one of the things we read in the original spec, and that hasn't changed. What has changed in EDID as we have gone from 1.1, 1.2, 1.4, 2.0, 2.0 A and B, now up to 2.1, is they keep adding more information requests within the EDID stream, making it more busy. In fact, you're going to see some of this information going off the traditional I2C wires onto the CEC wires. So there's going to be more data spread around as we go into 2.1. And it simply means your cables need to be good cables.
Yep.
So, when we're looking at our rise times, hold on a second. There we go. When we're looking at our rise times, we definitely want to make sure we stay under 700 nanoseconds. This is, the spec actually allows for 1100, and we've seen devices up to 1500 work. But don't take a chance. The lower this number is, in fact, if you can get down to 300, that simply means you're slamming that door. You're getting the attention. And as I mentioned, the Junior 3, the AIO2, these devices do that. By stripping capacitance, you're not dealing with an 1100 or 1500 rise time. You're dealing with typically 275 to 350. The current is not supplemented by the Junior 3. It's an entirely passive device, and it doesn't pull any current, so you don't have to worry about that. Where the AIO will help you with current if you've got a lot of devices or an active cable online. Also, when you're looking at these devices, they are minimal loss. These are 24 gigabit boards on all these products. That means it's 4 channels at 6 gigabits per channel. I'm guessing he hasn't found it yet because he's still looking. Most of you, or a lot of you, or some of you anyway, have certainly been to my classes and have seen me talk about EDID. Without question, this is the #1 most important thing for you guys to deal with in the field, because without it, nothing else happens. Keep the Junior 3 and the AIO2 in your truck. Buy good quality HDMI cables, because the better the quality of the cable, the less likely you are to have HDMI EDID problems. Make sure that in your rack, your gear is well ventilated.
Yep.
Now, we've got a lot more EDID to talk about next week.
Yes, we do. And in fact, what I've done, I just went and asked Stuart to reach out to DPL Labs.
To find out the data rate?
To find out the data rate, yeah. Because honestly, I don't know, and it's a really good question. I'd like to know.
And I don't remember.
Yeah.
Now, we took a really good call about this morning.
We did. Now, before you jump into that, I want to talk about the comment that we had from last week's episode. Because it was a really great thing, because you did actually already start to talk about it. And it was...
yeah, we get called out.
Yeah, from a friend of ours who is, I think, subscribed to the channel now. If you're not, subscribe if you're watching. But with that...
Because you're right.
You are right. And so what we did, basically what we got told about was that the way that we described current versus voltage... was
voltage essentially getting pushed, current being drawn.
Correct. Now, the reason that we described it the way that we did, and you can go back and look at the comment as well and how it's worded and whatnot, but essentially what it comes down to, the reason that we worded it that way was... we're in a limited time frame here, and so in order for us to go into great detail about it, we have to shorten things down a little bit. But essentially, we were saying that voltage is pushed and
generated.
Current is drawn, and so there's actually it's a little bit more minute than that.
Here's the thing: when you're looking at voltage going down a pipe, think again as the roadways. My description is the voltage is the roadway, the width of the roadway.
Right.
You can have too much road going into too small an area where you have to cut off lanes.
Yeah.
Or you're just going to overload it. So it is easy to overload something with voltage. You throw 24 volts DC into something that's meant to take 12, you're going to damage it.
Yeah.
Unless it's got diode protection. The thing about current is you could have a 100 amp current, 100 amp power supply, if you were willing to spend that much money, on a device that only needs 55 milliamps, and it's still only going to draw 55 milliamps. It's only going to take what it needs from that supply. One of the salesmen came in earlier, and we were discussing this. I gave him a gallon jug.
Yep.
Okay, here's what I'm going to do. I'm going to give you a gallon jug of water. Now, you're going to carry this gallon jug of water around with you all day. How much of it do you actually need to drink to quench your thirst?
Sure.
If you're sitting at your desk all day long, you don't need to drink much of that water. But if you're out cutting the lawn, mowing, sweating, you're going to drink a lot of that water.
Yep.
That gallon is the voltage. The current is how much of it you take.
Right. So, and actually, it's actually from our friend. I'll actually read the comment from Alex Andro ATS. He's saying that where to go? It is the amount of force that is applied to a conductor to induce or begin the flow of current. That's actually probably probably one of the best ways to describe it. And then he
smarter
went on,
than mine.
Yeah, and he went on to actually talk about how this is applied. He says, much like the amount of force you need to squeeze a tube of toothpaste, whether you decide to use your fingers or a sledgehammer. So the cool thing about that's a really good analogy, because if you're using your fingers, that's the correct amount of voltage to get the toothpaste out of it. But if you use a sledgehammer, what's going to happen? You're probably going to blow the seams on the toothpaste before you get the correct amount of toothpaste out of it. And so you're going to burn it up and blow it up. And that's what happens, when you give too much voltage into a system that doesn't need it. So if you put 12 volts on a 6-volt system, you're going to fry it.
Now, what happens if you put 6 volts in a 12-volt system?
Well, you're not going to get anything out of it, but you're also going to fry it.
Unless it's properly protected, because it's starving.
Yep, exactly. Which is an analogy for that. I'm trying to figure out what that may be, other than just you're not feeding your lions enough, and your lions are going to eat you.
Yeah, they're starving. They're going to die.
But anyways, yes, so let's start talking about the tech call that we had earlier.
Now, this one, and this is going to, I think we'll wind up probably into a video series after this series is done.
Honestly, I think so, yeah. It was a great one.
So he is doing a video conferencing Zoom church distribution system using an ATEM, which we also use, the video switching device. And the problem he was having is he's trying to support multiple monitors. And one monitor off the ATEM was not a problem. As soon as he put a splitter in and threw an additional monitor in, it failed. So our first call was like, okay, let's try the EDID blocker.
I have the answer here, by the way. I'm not going to show you what it is.
Now, the EDID blocker, like this in yellow, strips EDID off the bus. Now, this is great, assuming you don't have to have EDID.
Right.
You're not going to put this device on anything that requires HDCP.
Yep.
Let me rephrase that. You're not going to put this device on anything that requires HDCP because it will not work.
Yeah, it won't.
You're not going to put this device on the output of a Mac computer.
Nope.
You're not going to put this device on the output of a Windows 10 computer.
Right.
What you can put this device on is security NVR DVRs.
Yep.
You can put this device on, say, an ATEM or other video switcher that's handling the inputs independently. Now, he first tried this going into a splitter, and it didn't work correctly, and we got to talk about it and realized he had a 4K panel and a 720p panel tied to the same splitter. It's like, well, that's going to be a problem. So, and I didn't realize it was a 720p monitor at this point. I said, well, you know, let's just try putting the EDID blocker on the output of the splitter to the second monitor. And it failed, and then it turned out to 720p monitor, and it's trying to take 4K in.
Right.
I said, well, do you have two monitors that are the same on your job? Yes, I do. So he took the ATEM, and for those of you that do not know, ATEM is a video switcher for streaming, for small studios,
Right.
things like that.
So anybody who's
It's a
aware,
Blackmagic piece.
yeah, Blackmagic. Thank you. That's actually where I was going with. So Blackmagic is a company that produces video cameras. They do video distribution, or not video distribution, but video broadcasting, switching and whatnot for large venues, small venues, news stations. We actually use it here. We have one of their ATEM minis, the older series of minis that
which will be replaced soon with an ISO.
Yes, it is, and we're really excited about that.
And for those of you who noticed, this week's picture quality is much better.
Yeah.
It is the new Blackmagic camera, 4K
Yes, it is.
camera.
Yeah.
So when I ask him to connect it to two panels that are the same resolution through the splitter,
Yep.
putting the EDID blocker on the output of the ATEM going into the splitter, it worked perfectly.
Yep.
Because the content he's creating does not require HDCP.
Right.
Now, honestly, there's going to be more testing involved in this. This is our preliminary indications.
Yeah.
He's going to get deeper into it, throw more panels on it. And he's getting one of our HDMI splitters that has built-in scaling.
Yes, so the CS-1X2, 1X4, or 1X8 HDM SPL5
does per port scaling.
Yes, it does.
So we want to find out if that will resolve the issue. Now, on the ATEM, we also noticed some issues with some devices going into the ATEM with proper clock speed.
Correct. So, and it's not so much clock speed, it's just frame rate. Anybody who's familiar with the ATEM series knows that most of them do not allow you to have different frame rates. And in fact, even the new minis, I don't believe allow you to have different frame rates. I think you're locked in.
Right, the number one input sets the frame rate for the entire panel.
Exactly. And so you need to make sure that all your frame rates are set to the correct the same frame rate, whether it's 24, 30, 59.97, or 60, or I think they don't support 120. But make sure that they're all set to the same frame rate, or else you won't get a picture. We learned that the hard way.
Yes, like minutes before broadcast.
Yes, we did. But we got it all to work great for that.
However, what you can do is you can use one of our matrices, which has the frame rate adjustment in it.
Yeah, that was actually kind of an oddity. It turns out that the GoPro doesn't like the ATEM as an input.
Right, and we ran it through
the matrix first, and then once we got it through the matrix,
it was the GoPro that started this whole thing.
Yes, it was, because we wanted to use a GoPro at first for our top-down camera. We're now using a Sony,
Canon.
Sony or Canon?
Canon.
We're using a Canon Handycam thing, which is actually, it works out pretty good. You guys can see the quality of that. We're happy with it. But as always, there's that. See,
it's not a Blackmagic,
but I'm very happy with this new Blackmagic, so we're very excited about that. So, everybody, again, thank you so much for checking in with us. Actually, Brent, I'm going to go check with Stuart and see if he got a response back from Jeff real quick.
Okay, now,
yeah,
while he's walking away, let's get a little deeper into EDID. Now, I2C is the actual bus. EDID is the data. It's called an I2C bus. When you guys are looking at your timing, you have to be very careful. The more devices you add, the greater the complexity. So when you've got a source, a cable, an AVR, maybe an extender, maybe a matrix or a splitter or a display, all of these devices will add deviations and capacitive loading to the bus. Please have the Junior 3 in your truck. It really will save your life having this. This is one of the things that we talk about in all the classes. It's probably 98% of your failures, at least going into 4K HDR. The hot plug interrupt on the AIO2 fixed a lot of those issues, but the AIO2 also, again, has the capacitive stripping built into it. So you definitely want to have that, and buy a decent cable. It does matter. Digital's not just digital. I don't care what some of the columns on the internet say.
Okay, so Heather, again, I did. So Heather, thank you so much for the question. It was a really great question, in fact, and we got an answer. So
is it 115?
It's nope. So first off, the serial connection, while it is technically a serial connection, it's not an RS-232 signal. It's actually I2C.
Right.
And so, and so with the I2C, it's kind of an interesting way that they do that it handles the baud rate. But if you do the calculations for it, you wind up with 100 kilobits per second baud rate.
Okay, I was close. I said 115.
Yep. So 100 kilobits per second, or if you want to break it down from there, it's 100,000 bits per second.
So it's its own independent
Correct.
That only works with, it's not like serial or 485, it's not
Right,
232 or 45.
where you could hook it up to a serial port on a
Right.
computer and send
Now,
some
there are
random
some
communication.
excellent readers. We actually have an RS-232 scope
Yeah.
for looking at that kind of stuff. That anybody that saw us at Denver a couple of years and Atlanta
Yeah.
and Indy
Yep.
saw the scope so we could show the rise time and the data. And now they actually have interfaces so you can do it on your computer,
Yes. So
which is awesome.
With that being said, everybody, thank you again for checking in with us. Next week, we are going to be going live again at 3 p.m., and I'm actually pulling up the video now.
And I believe next week we're going to go into specific issues and repairs for those issues.
Yes, we want to kind of break it down. So today's not so much showing you, we really just want to talk about what it is, what it's carrying, the communication that's going back and forth. We just kind of rounded up for today's video. Essentially, EDID is the communication, is that handshake, if everyone, that everyone says.
Everybody
Which,
talks, the handshake failed.
Yeah.
Well, the handshake didn't fail.
yeah, and it's not really a handshake so much as it is just a passing back and forth. It's a negotiation of information.
That's really what it is.
And so really it's
a
the
contract.
Source. The source is telling the display, this is what I am, this is what I have to give you. The display is saying, this is what I am, this is what I'm able to display.
That's really what it is. The source is asking, what can you do?
Yeah.
And guys, one of the things we talk about when setting up gear, do not select multiple resolutions. I refer to it as the what do you want for lunch syndrome.
Yeah.
When you're setting up your gear,
Save that one for next week, because that's a really good way to describe it. I know you really want to give it away now, but let's talk about that next week, because that's a really good one.
now we sound like the news.
I know.
Stay tuned.
Stay tuned. Stay tuned. No, honestly, guys, thank you again for checking in with us today. Yes, next week.
I swear there's more.
There is more. There is a lot more. So next week we're going to be talking about the EDID iceberg, because there's so much more beneath the waves that tell us more what's going on with EDID.
And why it fails.
Yeah, so it's not a handshake, because it's not. It's a negotiation. We'll talk more about that. We'll talk about the failures and how to fix them next week as well. Specifics about what the failures are, how to fix those failures.
And please send us your, send us your questions, because I would love to answer them in the video.
Yeah. So again, everybody, thank you for watching the video with us today. If you have more questions after the live stream, or if you're checking in with us after the fact and you're watching it watching it recorded, leave your questions down in the comments section below, or leave your comments down there. Even if it has nothing to do with today's episode.
Or if you just want to call us out.
That too. We're happy to hear that out. No, because we don't get it right every time, but we get pretty darn close. So with that, leave those questions, comments, and concerns down below. A like and a subscribe is always helpful. Hit that little bell notification to let us know that, or let you know whenever we go live, which is every Wednesday.
At 3 p.m., give or take a minute.
Yep, 3 p.m. Eastern time. So check in with us. Like I said, right now, this is episode 2 of a 6-part series where we're going to be talking about HDMI. It's the deconstruction of HDMI. And next week, we'll be talking about the EDID iceberg.
Which one of us is the Titanic?
Well, so today was, oh, Captain, my EDID Captain. Next week is the EDID iceberg. So, well,
we're going down, aren't we?
I was going to say, you're going down with the ship. So,
that's what I thought.
Yeah, no, I'm already in the lifeboat. So, yeah.
Women and children first?
Pretty much.
I see how this goes, yeah.
Yep.
Well, on that happy note, I'm Brent.
I'm Adam.
Thanks for joining us, and see you next week.
Don't forget, reboot early.
Don't cut your wires too short.
Reboot often. Turn off CEC and call tech support.
Please.
We'll see y'all later.
Do you want to do any did you knows?
I mean, we probably